I put together this session because I don't think people in the InterSystems community do enough data science, and it's really for everybody, not just data scientists. So our people are, much more data engineers and coders than data scientists, but we all have a certain, common area here in the middle of the Venn diagram where we do a lot of the same stuff. A lot of what we do, whether we're looking at data in terms of is it fit to use for an app, or whether we're doing some programming, we want to look at, is the data, is it high quality? How do you know if the data is of high quality? You got to figure out if there's missing values, how many are missing. Are the ones that are missing biased in some way, biasing the data set? Is the data evenly spread out, or is it weighted to a certain side? All this is data science. So if you're actually going to do a good job of looking at data quality, whether you're a data engineer or a programmer, you're going to have to do a lot of data science. Data science is not just about the high-end, the sophisticated stuff around AI and machine learning modeling. That's certainly the top of the pyramid of data science, but there's a lot of statistical methods that underpin those that you have to do. Feature engineering is all about doing these things before you go in and do model training and AI work. So that's what this presentation is going to focus on. So this presentation is about looking at some of those numerical methods and looking at our Jupyter Notebook implementation, looking at the software that we provide as a VS Code extension. So really quickly, these are a lot of words around the most basic things you can do to look at data. You want to measure its spread, measure the spread, and measure how its centricity, or how much it's centered. And those are kind of two different things. And so the classic example is a Gaussian curve or a bell curve. And the standard bell curve is one in which for 34% of the data is higher or lower than the mean. And then the next deviation, you have 13.5% about of the data. And then at the very end, you have this long tail, which is just about the 95th percentile. 5% of the data is out there. 2 point something percent on each side. So basically, this is a normal distribution of data, and the more your data looks like this, the more you can use various statistical methods. So if you don't have data that looks like this, it's kind of weird data. And especially in healthcare, if you're looking at measures of disease or something in natural phenomena, you're going to want to normally see, I think you're often going to want to see this if somebody's normal. And if you have a population which is not normal, it's going to deviate from a normal curve. So how do we know if we have a normal curve? You look at measures of spread, measures of centroid or centricity. So the range. Another thing you want to think about is how quick can you compute these things. Some of these are computationally expensive, and some of them are pretty cheap. The range, if you want to measure how far your data is spreading, you can take the difference between the highest and lowest values. That's a really computationally cheap thing to do. It's also not that great, right? But it could give you could be a decent quick measure. If your range is huge, if your range is like 1,000 and you only expected it to be 10, that's you quickly found out that you have a bad range, something's wrong. But usually things are a little more subtle than that in nuance. Another way to look at the spread of your data is take the interquartile range. This is going to smooth out a lot of really bumpy values. So if you take the difference between the 75th percentile and the 25th percentile, you're going to get rid of all those outliers, high or low. So if you had a range of 1,000, but there was just one point out there at 1,000, everything else was more around 10, That's a very misleading range. This will get rid of that kind of thing. And eventually you get down to standard deviation, which gives you this. In a normal distribution, one standard deviation is 34% out, and then 13.5% out, and so forth. So looking at your standard deviation number will tell you how nice your curve is. Measures of the center, I'm not going to go as deep into this, but this is pretty obvious, right? It's very interesting to know whether or not the center is in the middle of the range to look at normal distributions, or whether your center is far off of other measures of center. It's numerical ways to give you a better idea of what you can also look at. We're going to do some visualizations too. But there's also computationally cheap and expensive ways to do this. And I'm going to go faster through those because you know what a median is and a mean. So this is what I'm not going to show, which due to COVID last week, I didn't have time to do a k-means analysis on this data. But another really interesting area to look at is once you get data that looks kind of clumpy, well, give me a numerical way to look at those clusters, because I may want to study a particular cluster in depth. And that's what some of this cluster analysis stuff will allow you to do. And after that, then you're getting into real machine learning models and AI models and things like that. But let's talk about the software now a little bit. So we recently sponsored the creation of an open source project around Jupyter Notebook work. And let me describe that better. So we have, if you just wanted to use Jupyter Notebooks, first of all, who uses Jupyter Notebooks? Who knows what they are? About half. Is anybody wanting to know more about Jupyter Notebooks? How they Okay. So Jupyter Notebooks, the quick 2-minute introduction to what they are is, it's a way to combine notes and annotations about your data along with the actual code that works with your data and along with visualizations of the data. And then, so you can put all those things together. Unlike a code file, you can have some comments in a code file, but you can't do bold and italics and bulleted lists and things like that, which makes it makes your notes a lot nicer. You also can't put graphs in code. And a really important thing about notebooks is that once you generate the graphs out of the data, the graphs stay there. Even if you disconnect from the data, you can't see the data anymore. So theoretically, like 18th century scientific notebooks, a Jupyter notebook can be dynamic when you want it to be, and then you can save it for hundreds of years, potentially disconnected from its data, and that the results of your work will live on for a while. So Jupyter notebooks are a great way to share information, around your office even, if not broader. If you want to do Jupyter notebook work with InterSystems, you can just use off-the-shelf tools. There's nothing special. If you want to do client-side Python or Java or whatever mainstream language you want to use, you can just use, for example, VS Code's built-in Jupyter Notebook extension and go to town. Use it with a JDBC driver, for example, or ODBC driver. Make SQL queries to InterSystems IRIS and create a data frame, and you're good. That's client side, which is great. What we helped develop was support for doing Jupyter Notebook work with embedded languages, SQL, embedded Python, and ObjectScript. So now we have an extension which will let you do all this code close to the data. And the whole reason for this session is, well, data science is one of the areas where it's most important to do, programming close to the data. If you ever want to get something into a NumPy array, Or if you want to do TensorFlow modeling, a lot of that's very computationally, data-intensive computational processes. And that's the kind of situation which is best suited to having your code close to your data. So I thought it was really important that we try to support or seed the coding of this extension so that it's easier for people to do notebook work close to the data. I'm going to go through some fun little examples of the statistical methods we taught, or the numerical methods we talked about. This notebook is PyClient, and so we're going to do client-side stuff. I chose to use Python and an ODBC driver. So we just instantiate that, put in some configuration information, and I hope I have this on the next slide. Yes. So down at the bottom, I import my pandas library. Pandas is the most popular library for doing data science. And I say that slowly because I think there are better options out there now. Just in the last couple of years, this area has really gotten better. So we import pandas and we import IRIS. And then we go to create a connection, create our ODBC connection, and we do a SQL statement, select star from a table, and we get a data frame. We do a read SQL command, pd.read_SQL, and we get that gives us a data frame. Data frame is Panda's main object used to work with data. That exposes a whole lot of really nice convenience methods to do good things with the data, which you could probably do with NumPy with more complex code. But Pandas is really a library that gave you much more intuitive, good methods to describe the data. So you can just do a sample command, see the first 10 lines. This is what people always do, just make sure it's working, sanity check. And now we go through some of those measures we talked about. Like I said, Pandas is really good at being intuitive, so somebody just happened to get it right with what statisticians learned in school. They used the method names, which basically match the names people were used to using, I think, is the key. The magic UI, UX that they did. So you just do max, min. You want a range, you do max minus min. You want that interquartile range, which sounded hard, but it's really easy in Pandas. GNP. I created a convenience name for one of the columns in my data. It's gross national product. And so I just called that column GMP, set a variable, so I can do gmp.quantile 0.75 minus gmp.quantile 0.25, and I get that interquartile range. Just checking on my time, I have 5 minutes left. Get to the good stuff. Okay, so, and we get some measures. So let's look at those measures of spread. So the range is huge. I can't read either one. The range is more than 8 million. I mean, the max is more than 8 million, the min is 0, so the range is more than 8 million, but the interquartile range is only 29,304.5. So what does that tell me? That tells me there's lots of numbers, either very high or very low, or both. Because that once you make quartiles, that range really narrows down. And I'm not a good enough statistician to tell you what the standard deviation number of 638,000 tells me about the shape of the curve. And then measuring the center, we look at the mean, the median, the mode, and the mid-range. So mean, average. We end up with 122,000. If we looked at that with our 600,000 standard deviation, that would probably tell us something. But the mean of 122,000 is very different from the median of 4,787, like orders of magnitude bigger. So that, once again, means that there's probably some numbers way, way high. And the mode of 0 means the most common value is 0. that could be interesting in that the data's wrong, or it could be interesting in that everybody has a measure of 0 GNP. I don't know. Some very messed up countries, I don't know. And the mid-range of 4,025,250 some thousand, that could be fine. Okay, so those numbers aren't that meaningful, so let's look at some quick charts. The point of this is to say don't be too intimidated by doing charting in Jupyter Notebooks or in Matplotlib. It can be pretty easy. Actually, one reason for doing this presentation is so you have some templates. You can go to GitHub and grab all this code later and take a look at it and see how to get going very quickly. So I just say scatter plot. Create import Matplotlib, figure, comma, AX equals plt.subplot. So some simple setup code. And I just basically say I'm going to do a scatter plot, ax.scatter. I'm going to specify which are my x and y axes. And alpha is just a percentage of transparency on the dots, so I can see through them. And if they layer up on top of each other, it'll get darker, which is a nice visual feature. And then I just create a grid, label the axes, and I show it. So it's not too bad to get started. Plot can be very, very messy and spaghetti code, but you can start off pretty easily. So what I'm trying to do here, this is a data set on, now I'll talk a little bit about the data. Data set on countries, and one of their various attributes of the countries. Two of them are gross national product and population. And so if you're trying to understand, if you have good country data, or trying to understand if the why gross national product increases, what influences gross national product, you might do some of this stuff to, chart this variable against other ones. So here I'm seeing gross national product on your left. Gross national product, there's a lot of zeros where population is 0. And then we have this one line that goes up. Gross national product really increases along a certain line up to a population of about 200 million. So there's one trend that goes up very quickly. There's another trend that kind of goes up slowly. Maybe this is a trend because I have 2 points out here on the edge where there's a low gross national product with very, very, very high population. Are those two different trends? Do they actually have some structure behind those data points, or are some of them just random outliers? Let's get rid of the outliers. So this chart over here zooms in on a smaller proportion of the data. Everything below 0.2. This is an exponential notation, so 0.2 is, I think, 200 million. And so we look at just that area right in that first grid, and this is what it looks like. And we still see two kind of trend lines. One is going this way, and one goes up higher. So maybe there's something behind that. So what would we do next? Maybe we would look at some higher, or maybe we do some clustering, or maybe we compare it to other variables, or maybe we compare it to multiple variables and do multivariate analysis. Those are beyond the time frame of this talk, which I have one more minute. So, you could go much further with that, but today we're just going to talk more about the software, a little bit more. So that was all done with the client-side Python, like I said. And we have this new extension, which will be referenced in the GitHub repo that show at the end, which allows you to do embedded Python in a Jupyter Notebook. And so the client side is fine with my toy data sets of a few hundred records, but what if you had a few trillion records or a few billion? You probably don't want to be doing a lot of these numerical methods we showed you have to operate across all the data. You don't want to do that over a small client-side pipe, probably. If you can avoid it, you probably want, when you operate across all the values in a column, you probably want to be closer to the data. And so it could be useful to use the embedded Python or even object scripts. For a lot of these methods, you could do them in object script. But there's so now we have a Jupyter Notebook extension for embedded languages. And if you follow the instructions, you'll eventually end up using an IRIS kernel. It'll be IRIS Python, IRIS SQL, or IRIS object script. And deciding what kernel you use will tell you that you're actually using an embedded language. If you don't understand that, that's probably a 10-minute discussion, which we can talk about at Tech Exchange tomorrow about notebook kernels. But the instructions will tell you how to set that up. And the point of this slide is to show you that once you get set up, there's no credentials to put in because connecting to IRIS gave you your credentials. And then you can just instantiate a pandas data frame very quickly now. You still run a SQL select statement to get a data frame. And then I identify my GNP column. And then you run through it. The code would be exactly the same. There's no difference. So all that's different is getting to the pandas data frame step. And that's it. And so there's a lot of good technology out there to help you do Jupyter Notebook work, and please do more data science before using your data in anger. Thanks.